Awesome. Well, welcome everybody. Glad to have you all here this afternoon, this morning, wherever you're tuning in from, to join us for the Lunar Surface Science Workshop that is today going to be focused on science accomplished with a robotic arm. So again, we've kind of got a joint effort today from SMD with some support from HUMD and STMD to pull this together. Deborah, I don't know if you have some opening words you want to say before we kick off the slides?
Yeah, just a quick note. First, welcome everybody. Thank you so much for joining us today. It should be the start of an interesting discussion that we'll introduce today as part one, and then the part two of this workshop will have more of our typical LSSW breakout session discussion that we'll uh, revisit at the end of the month. So it'll be a fun month. We are gonna have some homework for you if you're interested in contributing to that conversation. So stay tuned, and we'll have more information about that. One update that I did want to give in the schedule, we've had a schedule adjustment. Jake and I will be covering the kind of an overview of mobility in this introductory presentation. So our talk is going to take closer to 30 minutes rather than 15 minutes because we had a last minute cancellation of the topic. So just, and please, feel free to ask questions. We'll have folks monitoring the chat. And so put questions in the chat if you have any as they go, and we'll address as we go.
Awesome. Thanks, Deborah. So yeah, I think just a little more of an explanation today. So um, many of you will remember in 2018 we had a workshop dedicated to the gateway. I think at the time it was the Lunar Orbiting Platform or Lunar Orbiting Gateway. I can't remember what the name was at that time, but basically, when we had in formulation the gateway, and that workshop was focused on discussing payload ideas that could potentially have taken advantage of an orbiting platform around the moon in the near rectilinear halo orbit. So NASA used that workshop as a means of kind of setting a baseline for understanding what types of science might be accomplished from that platform. Now that meeting, 2018, we were very much in person, and we held that in Denver, Colorado. And what we did for that workshop was we released shortly before the workshop started a template that we used and asked the authors of the abstracts to fill out for us that gave us some more technical information about the payloads that they maybe were discussing in their abstract and their presentations. So we pulled that template together, and the thought was we could then pull from the template data to help us kind of look at and kind of put bookends on the types of payloads we might expect to see down the road proposed to something like the gateway. So that data was used and was useful to us as Gateway moved through formulation and transitioned into a program. Um, but we recognized after that workshop that we never really fully explained the template. We kind of gave that to you at the last minute and asked you all to fill it out. And so we got a pretty good variety of information. Some folks weren't prepared to fill that out. Others were more than happy to fill it out. Others just didn't really know how to fill that information out. So we learned a lot from that workshop, and in fact, it was the basis for the initial lunar surface science workshop, which at the time that we pulled it together was intended to be also in person in Denver, I think in April of 2020. But as we all know, things changed significantly with COVID, and we were not able to have that in-person meeting. And so what we have done was evolve that lunar surface science workshop into a series of workshops. First, addressing the main points or the main topic areas that we had intended to hit with that workshop, but we've evolved it even farther to basically propose concepts that help provide information to NASA as we continue to move along with developing the Artemis architecture. So you've probably seen folks like Kelsey Young presented at League last week, kind of an overview of where we stand with the lunar surface science workshops, um, how the information has been used. And so various topics have been used in different ways, but they have definitely been useful to SMD, HEOMD, and STMD over the last year. So today, what we are hoping to address is gathering information from you all, from the community, about how you might look at using a robotic arm on robotic assets that are part of the Artemis architecture moving forward. Um, we're hoping to conduct this similar to the way the Gateway workshop was run, in that we will request filling out a template, which Debra and Sean we'll go over at the end of this first meeting. But what we realized from Gateway was, because we didn't really explain how to fill out the template, we didn't really optimize the type of data we got back from everybody. So what we've done for this workshop is we've split it into two sessions. Today, we're going to have a review of some of the ways arms have been used for NASA exploration in the past. Um, and then we will present to the community what the template looks like and what we mean with the fields that we have in the template. Basically explain how to fill out the template. And then we'll give you some time to fill that template out over the next month. And then we'll have a concluding workshop based on the information you give back to us in those templates, that will be more like the traditional type of workshop where you give your presentations. And that will be later in the month, on the 30th, I believe. So I just want to kind of explain this specific meeting today is going to have a slightly different flavor than what we've done so far, but it's because of the way we're structuring this and how we're trying to fine tune the collection of information from you all to make sure it's as useful as possible. So with that, we'll go ahead and next slide, please, Kelsey. So today, this introduction will be from myself, Debra, and Sean Azimi, who's also going to help us out with the template. Now, what I would like to do with a couple slides here is just kind of go over the Artemis architecture, what we have envisioned. Now, many of you have probably seen this, and I will try not to be overly redundant, but I do think it's important at the beginning of these workshops to make sure we're all starting from kind of some common ground of understanding. And so I'll show these two charts. We refer to these as the swoosh charts. And this first chart is focused on what we're doing in order to get to the point of landing astronauts in the South Polar region of the moon. And so as you look at this chart, as we move from left to right, we're showing kind of a sequence of activities that we expect to undertake. I think it's really important to note right at the top left corner there, this is all based on our understanding from prior missions. And so we have drawn up Lunar Reconnaissance Orbiter here because it's still in orbit, so that we consider this kind of a starting point to the Artemis effort. But this builds upon, all the missions that were predecessors to Lunar Reconnaissance Orbiter as well. But that has given us a very good understanding of the moon. We know the topography. We have very high resolution images. We have well developed theories and hypotheses over the last several decades that have built upon what we learned when we landed on the moon during Apollo. And so from that basis of knowledge, we really are planning a new campaign for exploring the moon, um, knew just right from the get-go, and landing in a totally different place, not on the near side equatorial region, but in the South Polar region. And landing there for a number of reasons with astronauts. One, to take advantage of access to sunlight. That's kind of our number one resource that we'll be using. Because unlike elsewhere on the moon, when you spend half of a lunar day in sunlight and half of a lunar day in darkness, there are some locations here where we can really go from that 14 Earth days of darkness down to maybe a few days of Earth darkness. And so that's a tremendous asset to us, a tremendous resource. Also, the South Polar region is a location where, based on all that knowledge we've gained over the last several decades, we think we can access volatiles as well. And that will be a really important piece of data for us understanding evolution of the solar system, evolution of the moon and the Earth itself. So there are a number of reasons why we're going to these places in the South Polar region. but it's part of a campaign of exploring the moon. And that's what we're trying to show here is how our directorates are working together. The swoosh part, the blue swoosh right there, shows the HEO launches that we expect to conduct in order to prepare for and successfully conduct that landing on the surface in the bottom right-hand corner of the chart. So we have a series of Artemis missions that will provide us with test flights of the Orion spacecraft launched on the SLS that will give us a chance to, one, test out the hardware itself in Artemis 1 and then test it out with our astronaut crews in Artemis 2, all while traveling out to the moon and returning safely. We'll also be putting in place the Gateway, as I mentioned earlier, kind of the workshop that helped us kick off this whole idea of workshops. So the Gateway will serve as a platform from which we can continue to conduct research both in orbit, learning how to survive in deep space, as well as helping support activities on the lunar surface. And all of this leads up to a crewed Artemis mission that will land on the surface, which will be our first humans on the surface of the moon in the 21st century. Now, HEO is conducting those, or HEOMD, Human Exploration, is conducting those missions with the Orion and then the Human Landing System. But all the while, we will be continuing to land landers on the surface of the moon through SMD's CLPS, Commercial Lunar Payload Services. So there's, as SMD can certainly explain in more detail and has over the last several months, there are missions already identified for landings on the moon, and there will be more coming up. And so as you think about this, what you're seeing is that we have opportunities for science and technology research, both in orbit and on the surface of the moon, with activities that would also include astronauts in the South Polar region. Next slide, please. Now, once we get that first crewed landing down to the surface, we will start to build up assets, both on the surface of the moon as well as in orbit. So Gateway will continue to have elements delivered to it that will increase capability in orbit. So as I mentioned, the Gateway provides a platform that supports our activities on the lunar surface, but also provides us an opportunity for learning how to survive in deep space, so beyond low Earth orbit. That helps us prepare for further exploration in deep space beyond the Earth-Moon system. But in addition to our buildup in orbit, we will continue to build up on the surface as well. And so we talk about an Artemis base camp buildup. So there are a number of assets that basically make up our concept of a base camp. We will begin to deliver habitable volumes to the surface. Those could be stationary habitats. Those could be mobile assets. Preceding that, we will also be delivering hardware that enables us to move astronauts and potentially payloads and science activities around on the surface, both with crew, but also telerobotically. Many of you have asked over the last series of LSSWs and League and other meetings about options for rovers and surface roving activities. These are all part of a vision that we have for building up capability and sustainable exploration of the moon. The goal here really is to continue to increase our access to the moon, increase the amount of time we're on the surface, increase the locations that we have access to. So what we're really trying to do here is develop a campaign for lunar exploration that's starting now with our CLPS landers over the next few years, leading up to our first crewed landing. Next slide, please. This is just an artistic rendition of, what a base camp might look like, some of the assets there. Between this picture and the prior picture, I think what we're trying to focus in on for today and for the template we'll ask you to fill out, and then the meeting later this month, is thinking about how we use these different assets to conduct research for technology demonstrations, for scientific research, for exploration in general. Some common concepts that we'll need in order to continue to explore the surface of the moon, conducting EVAs, mobility. I have the mobility italicized here because we'll talk a little bit about that in the next few slides as I hand off to Debra. But habitation, how do we survive on the surface? How do we power these elements? How are we staying in communication both with the Earth with assets in orbit like the Gateway and between assets on the surface of the moon. How are we navigating around the surface of the moon as we use our mobility and conduct our EVAs? And how do we take advantage of the moon itself and its in situ resources? So I mentioned sunlight as a key resource for us, but also the potential to access those volatiles that are stored in the polar regions. So the key here is that we'll have astronauts who are using rovers, we'll have rovers that don't need astronauts. So there will be a number of opportunities as we develop this campaign of lunar exploration in which we may want to use or access an arm of some kind. And so that's kind of what we're trying to get at today, beginning today, is understanding from you all what your vision might be for using a robotic arm of some kind, whether it's on a crewed rover that actually has crew with it, on a teleoperated rover with no crew. What is it that you would like to see done, and how do you expect to see that done with an arm? So Deborah, I think with that, I'll hand off to you now, and you can take it from here.
Great, thanks, Jake. So yeah, I want to go back to the mobility part because what Jake has been talking about primarily has been the mobility associated with crew activities. But we also, of course, have science can be done in conjunction with crew as well. Before crew is there, on the surface, after crew leaves, and as partners with crew from a science perspective. So, Kelsey, if you go to the next slide, please. We've certainly had significant discussions about how mobility stands to benefit science exploration, and certainly we all know very, very well that mobility significantly enhances our ability to achieve key science objectives. And this was covered specifically in the Artemis 3 SDT, where they outlined some of the specific enhancements and opportunities to science that mobility in general offers. And so, it enhances the investigations outlined, and again, in concert with crew activities on the surface. It enables and enhances the range of traverse measurements, especially those that are mapping large sections or more expansive sections of the lunar surface and subsurface. It also, of course, enables access to diverse geologic units and facilitates it potentially, with the correct capabilities, facilitates deployment of instruments over a broader area than may be accessible by crew on foot. Also, it allows mobility opportunities allow for carrying a greater number of specialized field equipment. So, if we have specialized tools, drills, things like that we want crew in particular to use, mobile assets, can be the workhorse and help transport that equipment out into the field alongside crew. And then it also, increases the time that crew might be able to spend in the field by reducing how much exertion crew has to exert when walking, so they can go farther, but they also can save their consumables as they're getting to the sites of interest that we want to investigate from a science perspective. So at the next slide, please, Kelsey. So a number of mobility assets are actually under development in support of lunar surface science, even without the presence of crew. And this, I want to highlight from a science perspective. Again, companion rovers or rovers that have the opportunity to go out in advance, to scout out terrains for crew, but also go to places where crew isn't planning to go. So these below. The examples that I have below are in the table are all, some of them are going to polar destinations, and some of them are going to non-polar destinations as well. Certainly have plenty of science objectives that are global to the moon, so we want access and mobility access to other locations as well as to where crew is going. So again, I think there might be an open mic, just be aware. So these are all examples of payload of rovers that are actually expected manifested or expected to be manifested on deliveries to the lunar surface via the CLIPS program. So the first one is scheduled to go late next year. It's a technology demonstration funded by STMD to demonstrate a hopper on the lunar surface, and so that's a different kind of mobility than maybe we typically think about, but it's going to be an exciting demonstration. We also have Viper, of course, that we are all very well familiar with, funded out of out of Planetary, to go to the lunar South Polar region, and it's carrying 15 kilograms of science payloads plus a drill that will be operating in concert with some of those instruments. Moon Ranger, which is a small rover that's going to be demonstrated on one of our early CLIPS deliveries. And that's going to be carrying a neutron spectrometer. So it's as a science payload to benefit from those capabilities as well, and gain other science data from instruments on mobile platforms delivered by CLIPS. And then, of course, we all have heard the recent announcement of Lunar Vertex as an early PRISM payload that will be delivered. We're excited about those opportunities as well. And then Cadre is a small technology demonstration with small rovers. And then the last two are the one that I want to especially highlight is the CLIPS mobility for PRISM 2A, which that call has recently gone out. So we're looking forward to seeing what you all have to propose for that. But this is an approach that we plan to take with CLIPS to enable mobility on future CLIPS deliveries, on certain future CLIPS deliveries, but where we ask the commercial provider to provide a rover to us based on the specifications that we science require. So that's going to be an interesting experiment going forward. Again, we're looking forward to seeing what you have to offer there. So this is the science perspective on mobility. And Kelsey, if you go to the next slide, please. Some of the use cases for mobility that we've had conversations about mobility already. That is not necessarily the focus of this particular workshop, but I did want to highlight some of the findings that we had come out of the earlier conversation we had on surface mobility. And this was from our October 2020 lunar surface science workshop. And the findings from that kind of span the uses of mobility and that we're trying to address with some of the examples of mobile platforms that I just talked about. So, again, and I mentioned this, and Jake mentioned this as well, that scout scientifically interesting areas in advance of crew. So this is, mobility and support of crew operations on the surface. And again, transporting crew and science instruments. But then also exploring scientifically interesting areas and accessible to crew, and whether that's in the South Polar region or, again, global to the moon to address key science objectives that the community has identified over the last several decades as wanting to address. Autonomous and or teleoperated systematic mapping, conducting unique geotechnical experiments, and deploying and retrieving instrumentation arrays across large areas. And many of these use cases that we all identified the last time we met to discuss surface mobility do require access to a robotic arm. And so again, as Jake indicated at the end of his section, this is what we're meeting this month to talk about is what specifically, what are the, and I'll talk about this in the next slide. So Kelsey, if you can go to the next slide, please. What specifically do we want to do with a robotic arm or robotic manipulator? In some of the initial discussions in putting this workshop together, we identified three primary use cases specifically for a robotic arm. And that's, including surface analysis, so, analyzing samples in situ with an arm-mounted instrumentation that needs close access to the surface for conducting those analyses. Collecting samples, so acquiring them and transporting samples from the surface onto, on rover instrumentation for further analysis right there and then, or to a sample stowage container for return to a location where we can return those samples, whether that's to another robot or to crew. And then the third use case we identified is instrument deployment. So transporting instruments from the payload deck of the rover to the surface. And again, we're going to invite you all to identify if there are additional use cases that we haven't identified here in the template that we're requesting for later, for submissions later this month. But those are the primary use cases that we've identified so far. And as we go forward, the key questions that we want to think about with regards to a robotic arm is what are the key science objectives that are achievable, and we want to make sure that we're using a robotic arm, in the most optimal way possible, and designing it to be usable as we need it to be. So what types of samples are needed to address key science objectives? And this is in regards to both sample access, so with the sample surface analysis in situ, and for collecting samples. So do you just need regolith samples? Do you need float rock samples? Do you need a core of a rock, or a core of, into the subsurface? Those types of samples, like what kinds of samples do you really need to address the science objectives that are the most important to us? And then what types of arm-mounted and deployable instruments and tools are needed to address the science objectives? So this is getting into more details about, do you need a drill? Do you need just something to scrape off that outer patina and get then put a contact instrument in place? That kind of level of information. And then what arm capabilities are needed to address key science objectives? And some of that might relate to the tools, but some of it's also, how flexible do you need the arm to be? How much pressure does the arm need to impart on the surface? Things like that. So those are the types of questions that we want you to think about, with the thinking of, we really want to prioritize what, or identify what the priorities are in the community for what these arms are capable of doing. And I think, oh yeah, please, the last slide, I think, Kelsey. So that's what we want to discuss over the next, the rest of today and next time. For today, the overview of this discussion topic. So we just talked about architecture plans and science motivation. That's what this particular talk was aiming to address. And we're also, the rest of today is going to be talking about, a potential concept for future robotic arms for lunar surface operation in particular, and then looking at some lessons learned from specific robotic arms operations on Mars, and then the science that's achievable using robotic arms on Mars. So talking about, what do we know how to do, and what are we doing with arms that have already operated on planetary surfaces? And then at the end, Sean and I will get on and talk about the preview of part 2, and with our request for community input. And with that, that brings us to the bottom of the hour. So again, if you have any questions, I note that there was a comment made that STMD is also supporting another technology demonstration on the surface, which also includes a rover as part of the experiment to test the cellular system on the lunar surface by Nokia LTE. So that's another demonstration that does involve a rover as well. So thank you for flagging that, Nicole.